All right, let's get started. All right, so welcome to week 4, everyone. If you haven't already, please fill out the attendance form. Again, we're shooting for that 90% attendance. So you can have food on week 5. Currently, for those who are coming in, we're I think one person short on week 2. So if you didn't fill it out for week 2, please fill it out. We're about like 14% short on week 3. So again, if you weren't here or you were here and you didn't fill it out, please fill it out. And then obviously, please fill it out right now if you're here. Again, if we get that 90%, I will bring food next week so we can have a little party for the end of this class. Um, but with that said, I'm just going to get started today. I'm going to be doing a lot of talking today. Today's pretty light, but just know that this is valuable information to you, and it will benefit not only you, but me later if you decide to print your finals. So we're going to mainly be talking about 3D printing today. So if you've been waiting for this part of the course, we're here now. Yeah, let's get started. Again, I talked about the final a little bit last week, but it's not too bad. You're just going to create your own model from scratch. You already have experience modeling things around a rule set, but now you can kind of let your imagination run wild to some extent. Obviously, it cannot be something that we've already done in this class, so please don't just like make an engineering final and or engineering fountain and submit it to me because I will be very sad. So please make something else. I encourage you to get creative and make something original. But if you want to copy something that exists in real life, that's totally fine too. Um, it just needs to have at least 5 design features. So technically speaking, you could have like 4 extrudes and a fillet that would work. But I encourage you to challenge yourself. Again, the requirements for this final are extremely lenient, and for some of these assignments, you've probably surpassed that. So you can definitely do it. The only thing I ask is that it must be designed with manufacturability in mind. So we're going to talk a bit about that today, but it'll help us when we print finals, and it's actually something, I can make and then give to you. Because, it'd be kind of cool to have something at the end of this class to kind of show what you got out of it. So I'm going to do my best to print all of them and deliver them to you. Um, but yeah, again, here's some photos of past finals. Obviously, these all have more than one or more than 5 design features. So, it's not that bad. Um, when is the final project due? Okay, the final project will be due a week after the last class. So the last class will be next Tuesday. So you will have 1 week from that last class to turn in your final projects. So yeah, please get them in like before that so I can start grading them and then, maybe start printing them. So yeah, we'll talk about that more later. Um, Also, you're going to be rendering your final projects. So you see in these 4 photos, they look really nice and professional and shiny. So that's going to be a part of your final as well. But yeah, we're just going to dive in today, kind of designing. We're going to learn about designing with manufacturing in mind, right? So I'm going to be talking about, manufacturability a lot. So bear with me. Uh, all right. So in general, there's kind of 2 types of manufacturing processes, right? The first one, which most of you might think of the most when you think about making something, is generally subtractive manufacturing, right? And that's when you take something like an object and then you cut away at it until you get your final product, right? So you see here on the left, we have this square, and then this tool kind of goes in, cuts it out, and then eventually you get this end product. Previous homework assignments. Okay. Previous homework assignments should be due the day of class. So if you didn't do your homework and you didn't turn it in, then it's technically late. If you have like, certain circumstances, like you had an exam or something, feel free to message me later and then we can talk about extensions. But um, yeah, your homework assignments should have been turned in before we came to class today. Um, anyways, that's this is subtractive manufacturing, right? Um, before class starts. Yeah. So I guess technically 5:29 is when it's due. Uh, but anyways, so here are a couple of subtractive manufacturing processes. Most commonly you might think of something like drilling a hole in something that's subtractive, right? You're removing the material to create a hole. Milling is very similar. And then there's also things like turning on a lathe or even routing on a router or grinding with like an angle grinder or a surface grinder. So these are all really cool, but we're not really covering this a lot, just generally because um, these manufacturing processes, at least some of them, are kind of out of reach for like the average person. Obviously, you can have a drill and you could probably buy one. But like a milling machine or a lathe is generally more difficult to come by for your average person. So we're mainly going to focus on additive manufacturing in this class. And that's basically the opposite of subtractive manufacturing, right? You start with nothing, but then you have some kind of tool that deposits material, and then it builds it up until you have your final product, right? So again, on the left, there's nothing, there's just kind of a build surface, and then you have a nozzle or some kind of tool that deposits material until you get your end product, right? Um, Obviously, there's a couple of different kinds of additive manufacturing. Ones that you may not have thought of as additive is injection molding. So stuff like Legos and just a lot of plastic pieces in general are injection molded. And it is an additive process, right? They have a mold, and then they inject or add material to it to create your part. But in this class, we're going to be focusing on 3D printing, mostly because as students, it's something that's pretty available to us. Um, and, you know, I have them at my house. There's plenty of them around campus. So they're getting more and more available to students and just the general consumer, which is pretty cool. Um, Obviously, there's a bunch of applications for 3D printing, aside from making, plastic desk toys that a lot of people think about. Um, it's been pretty, it's been growing in like the industrial sector for a lot of rapid prototyping and stuff like that. I know I'm currently on co-op right now, and we have a 3D printer where I work, and it gets utilized for a bunch of random things on like our assembly line, right? So it's really great for specialized stuff like that. And it is great for quick turnaround instead of having to ask, a shop for a quote. They'll get back to you in like 2 weeks, and then they'll take like another 2 or 3 weeks to, um, manufacture and then send it to you. So some people may think 3D printing is slow when you look at it on a part-to-part basis. But just because you can have the printer, where you are, it'll it makes it quick because you don't have to wait for shipping and stuff like that. Yes, you will need to download Prusa Slicer today. I will go over it in a little bit. Um, if you want to ask me about where I'm working, you can ask me after class. But yeah, there's a bunch of applications. These are just a few. Um, but yeah, there's a bunch of different types of 3D printing as well. We're going to be mainly focusing on one of them, but two other ones are SLS printing, which is basically using like a powder and then using a laser to like melt the powder and then adding a layer of powder on top of it and then lasering it and continuing that process until you have a 3D part. A lot of common material for that is something called nylon, if you haven't heard of it. It's pretty strong. It's pretty good stuff. Yeah, SLS is great. It's not super consumer friendly though, at least not right now. The more consumer friendly version of SLS is SLA printing, which is using a resin based um, like material instead of a powder. So it's almost like an epoxy kind of substance in the sense that it's a resin, and it cures with UV light. So they basically have like a TV or just a display on the bottom that emits UV light, and then it will emit a 2D profile of your part. It'll cure it a little bit. Your part will move up, and then it'll continue the process until you have a 3D part. Um, One other thing I haven't mentioned here is SLM, which is selective laser metal or something. I forget the acronym. But it's metal 3D printing. And it's pretty cool as well. But it's not super available to consumers yet. But the main one that we're going to be talking about today, and the one that you might all be thinking about, is FDM or FFF 3D printing, depending on whether you want to go with like the trademarked name or not. But basically, it just uses like a spool of material, and then it extrudes it through a nozzle, right? So I like to think of it as a really fancy hot glue gun connected to a robot. But instead of hot glue, it's just some kind of plastic or other similar material, right? The nozzle heats up and melts the material, while some motor or extruder feeds the material into the nozzle. Um, it'll deposit it onto some kind of build surface, and then it will build up the part um, just kind of over time, right? It'll draw like a 2D profile of it. It will move up a little bit and it will do it again. And you'll kind of, there's a kind of good way to visualize it once we get Prusa Slicer, and you'll kind of see how it works. Um, but yeah, it's basically just a fancy hot glue gun connected to a robot that precisely deposits material where you want it until you get your part. I'm going to be going into a bunch of settings, so bear with me. It's a lot of information, and try not to get too worried about this. But this is just kind of general rule of thumb stuff. So when you're um, getting your design ready to be printed, there's a bunch of different settings that you can apply to your model to create your part. So if you think of like normal 2D printing on like a piece of paper, you can kind of control stuff like dots per inch and stuff like that. But for 3D printing, because you have, you know, a third dimension and a lot more stuff, there comes a lot more settings that you can choose. Um, One of the first settings that you'll typically choose is the layer height. Um, and that's basically how fine you want the print to be vertically, right? So if you think about 3D printing, the reason why the softwares are called slicers is because it'll take your model, it will cut it horizontally into many, many slices, and then it will create like a tool path for the nozzle to follow, and then it will stack those on top of each other until you get your part, right? So your layer height is basically how fine those slices are. So if you want a really detailed model, you'd want to choose a really fine layer height, like the 0.1 millimeter layer height. on the right side here. But then if you're looking for a little less detail, you can go towards, less fine layer heights, like this 0.8 millimeter layer height. And you can kind of see the progression from left to right or right to left. The 0.8 is not very fine. You can see the layer lines, but then as you go finer and finer, it starts to become less noticeable. And there's definitely certain advantages and disadvantages. And a lot of the times, or not just layer height, but all these settings, you're going to want to choose the setting appropriately, right? So depending on what your use case is, you might want to use a 0.8 millimeter layer height or a 0.1, right? But that is for you to decide when you slice your print. So one of the advantages of really fine layer height is that you get a high level of detail, right? The layer lines are less noticeable, and if you have really small features, at least on the vertical axis, they will come out better. But it comes at the sacrifice of speed, and sometimes it comes at the sacrifice of strength, but that's usually somewhat marginal, depending on what you're doing. So the reason why you sacrifice speed when you go at a fine layer height is because your printer needs to print more layers, right? And the more layers that it has to print, the longer it takes. So the finer it is, the longer it takes. Obviously, the inverse is true. So if you have a very rough surface finish, or really like rough layer height, then it'll print a lot faster. And sometimes it'll be stronger. And this is the reason why it can get stronger is because there's less layers, and layers are kind of a point of failure for 3D prints. So if you design any engineering parts, the orientation at which these layers are placed is something that you want to factor in, because the bonds are kind of weaker in that direction. So if you were to hit it in that direction, it can kind of shear and break. But that's getting a little bit more technical. But yeah, that's layer height. Um, there's a bunch of other settings like perimeters. So the perimeters is what some people consider as the wall thickness, and that's just kind of how thick the outside of your 3D print is, right? So you can see here on the left here has two perimeters, and you can see it progressively has more and more as you go on the right. So the left is really thin, and it'll print quickly because there's less lines for the printer to make, but it may not be as strong, right? So generally, if you want a stronger part, you can increase the number of perimeters to make the outside stronger, right? Obviously, when you do that, you sacrifice a little bit of speed, just because there's more material, and it'll just take longer because you have more stuff to extrude. So again, trade-offs. Infill is something that's also pretty important. It kind of pairs with perimeters. So the perimeters is the outside of the model, but the infill is inside, right? So if you didn't know, most 3D printed parts are actually hollow on the inside because you actually don't need a lot of material on the inside to get most of the strength, right? It's actually, in many cases, a good idea to increase the number of perimeters instead of increasing the infill if you want a stronger part. But basically, the infill density is just kind of, how dense your part is. So you can see here on the left at this 10% infill, it looks very hollow. This honeycomb structure is very large, but then as you go higher and higher, it becomes more and more solid. So depending on your use case, you might want more infill for better strength, but obviously, that increases print time, material cost, and stuff like that. Supports we're going to get into in a little bit but basically you kind of need to use supports depending on the model, or at least some models are limited, and you'd have to use these. Basically, how 3D printing works, again, you're just printing layers on top of each other. But if you try to print something in midair, it's not really going to do well, right? So you see here on this model, we have this cylinder sticking out to the right. And if the printer was to print it without supports, it would just print in midair, right? And it would cause the filament or the material to droop and then ultimately fail. So depending on your part, you might need to print something like a sacrificial material to hold it up. So that's what supports are here for. So you can see in this photo, there are these kind of gray lines here, and that is support material to make sure this part gets supported so the print finishes like correctly. As a designer, if you're designing for manufacturing, at least for me, I try my best to make sure that I don't need to have supports in my models, right? Sometimes it's unavoidable if you really need a certain geometry, but again, as a designer, you can try to challenge yourself to design the need for supports out. And that will reduce the amount of material that the print costs, just because you don't need that sacrificial material. Um, you don't need to post process it because when you print supports, you have to take them off after you print it. So there's a couple advantages to designing out supports, but sometimes you need it and it's unavoidable. So here's another example of supports. You can see how this H is like an overhang. So sometimes you might need to support it. Obviously, some of these things may not need supports if your printer is tuned really well. But in this case, this person printed supports for this H. Um, Another thing to keep in mind is that you can change the print orientation, right? So in this photo here, this H was printed like from the bottom up. But if we laid it on its side, we could have just printed it without supports. But again, depending on the layer line orientation, it may or may not be what you're after. So yeah, that's just kind of the end of my little spiel for now. We're going to go into Prusa Slicer in just a bit, and we're just going to start slicing parts. Uh, Slicing parts will kind of give you a good idea of what the printer does and might give you a better idea of how everything works together. So there's a bunch of different slicing softwares. Again, we're going to be using Prusa Slicer today, but um, similar to all the CAD programs out there, there's a bunch of slicer softwares. Many of them are free and open source, like Prusa Slicer, but there's a bunch of different options for your choosing. Um, Personally, I like Prusa Slicer because I have a couple Prusa machines, but I also utilize Orca Slicer, which is actually a derivative of Prusa Slicer, but I won't really get into that today. So let's just jump in and download Prusa Slicer. So if you go into the Discord, wrong channel. If you go under resources, I have this link here to Prusa's website. Um, if you just click it, it'll open up your browser, and then you can download Prusa Slicer. So download it for your machine. In my case, I have Windows and I've already downloaded it. So I'm just going to launch it. But Just run through the download, and you should be good. I'll give everyone a couple minutes to do this. Does anyone have any general 3D printing questions? Yeah, I'm kind of like a crazy 3D printer guy, so I can do my best to answer any questions you may have.
Hi, Andrew. Like, say for example, you're trying to do some like FEA on a thing you're trying to 3D print. What would
Mhm.
you set the material to?
I mean, you would just set it to like the material that you're using. Generally, like a common plastic would be like a PLA or a PTG. I actually primarily print in something called ABS. So if you're doing FEA, ABS is, not a bad material to go with. Um, PTG, I think, is a little bit stiffer than ABS, but it doesn't have a great temperature resistance, which is why I don't generally use it. Um, I'm going to be talking about materials a little bit next week. Um, but yeah, just to get a general idea, something like an ABS or FEA would work. Okay. Has anyone not downloaded Prusa Slicer yet? Or if your download is slow, feel free to let me know. You can't download it. Okay, I'll wait a couple minutes, see if everyone can figure it out. For those of you who are wondering about your like score in the course, I haven't finished grading yet. So um, you'll receive an email from the Gmail account that you submitted all your Google Forms with, and it'll give you your scores um, for the weeks when I release them. And I'll send out a message when I do release them. So um, yeah, don't worry, don't freak out. Everyone's doing pretty good anyways, so I'm not too worried about anyone unless you just don't submit anything. Okay, yay, it worked. Okay, cool.
Is there a
So,
problem if I've submitted the forms with different email accounts?
no, I mean, it's like the main roster is tied to your Purdue email account. But whenever I release the scores, it sends it to the email account that uh the Gmail account. Just because it doesn't send it to the Purdue account. So yeah, don't worry if you didn't use the same email every time because I have it all logged under your name and your Purdue email. So it's just the way the Google form delivers the results. But yeah. Okay. I'm gonna assume that everyone has Prusa Slicer up and running. If you don't worry. You can just follow along. And catch yourself up either after class or right now. But you're likely going to be open. You're likely going to open to like this configuration wizard. For me, I've already downloaded it, so it kind of skips it. But you kind of want to choose your printer. So in this case, we're all going to choose the same one, so all the times and stuff like that match up. But this is where you would select your machine, right? Um, in our case, make sure you just select the original Prusa Mark IV with input shaper. For the nozzle size, we're going to use a 0.4 millimeter nozzle. That's pretty standard. So make sure you have that checkbox checked out off, because I'm going to be mainly going off the time of your slice part for the assignment that we're going to do in a little bit. So if you're using the wrong printer or you're using the wrong profile, you're going to get the wrong time, and then you won't get a full score on this assignment. So again, choose the Prusa Mark IV with input shaper, and then we're using the 0.4 millimeter nozzle. If you had more machines here, you could, choose them, but I'm just going to leave it at that for now. And then I'm just going to press finish. So this is kind of your user interface for Prusa Slicer. What about the printer? You should be using the Mark IV. Okay. I have a bunch of them here. Yours should look pretty bare. So yours should look like this when you select the Mark IV. Yeah, sure. So if you ever accidentally closed it, you can just go under the printer tab and click add or remove printers here at the bottom, and then add or remove presets. It usually takes a minute to load, so yeah, give it a second. Okay, so you'll be greeted with this welcome screen. I'm just starting with Prusa FFF and selecting the Mark IV with input shaper. Obviously, there's a bunch of other brands and stuff like that with pre-made profiles. Like, for example, like, have a Boron, they have pre-made profiles, and you can use them to, build your printer or to slice parts for your printer. But yeah, Prusa Mark IV input shaper. I'm just going to press finish. You'll probably be on simple mode, just because, if you haven't done it before, is staying at simple will just kind of limit the number of things that you can change and kind of simplify things. But as you should choose the Mark IV with input shaper and the 0.4 millimeter nozzle. But yeah, as you get more advanced, you can change the modes to unlock more settings. Filament, yeah, I think filament kind of does matter. It'll just kind of, change like cooling settings. For this, we can just leave it as, let's just do generic PTG for everyone. So I'll make sure to note that down for everyone. Please use generic PTG, because sometimes depending on the filament, it might slow it down or speed it up. So use PTG. And yeah, again, so right here on the left or kind of the middle, you have your build plate. So it's just kind of a virtual representation of the build surface on your printer. So this is where you're going to place your models to be printed. On the right side, you can see there's a couple of settings. mainly right here, which is the layer height, the material, what kind of printer you're using, enabling supports, and then infill. Um, there's a bunch of other settings that we can open over here on the top. There are these tabs here. So if you want to change other settings, you can go under print settings. And then you can see that there's more stuff to change. But I'm going to import a model, and then we're going to start to slice it. So for this assignment, I'm going to have everyone download the 3D Benchy, which is a pretty classic calibration test for your printer. Generally, if you can print a good Benchy, then you can print, you know, most of the things that you're going to print afterwards are going to be pretty decent as well. So if you want to go in the Discord and download it, it'll take you to this website called Thingiverse, which is similar to like GrabCAD and stuff like that we did last week, but it's a repository mainly for 3D printing. So here's the classic Benchy. Just download it over here. Make sure you download the STL file. That's what you want. They have a bunch of other random parts of it, but we want the whole one, the whole thing, which should be the second one. So once you download it, you want to insert it.
Wait, can you go back to where it said download?
Yeah, sure. Don't click that. It's an ad. The download button, it should be on the right. If it starts at thing details, you just click on files and then you download it there. But yeah. The printer you selected does not have input shaper in its name. Yes, it does matter because if you chose like the Mark IV without input shaper, the estimated time will be very different. Input shaper is a thing that makes printers go faster. Yeah. This is kind of like technical, but basically what it does is it cancels out like vibrations that your printer makes. So like if your printer resonates at a certain frequency, the printer can detect that and then cancel it out. So it doesn't vibrate and leave print artifacts. But that's a little bit more technical.
All the printers, they input sharpener at the top in green.
Mhm.
I have the original Prusa MK4S with 0.4 nozzle selected. Is that right?
Yeah, okay. That's probably fine. I think my Prusa slicer isn't updated, so I don't have the Mark IVs yet. Which I could probably update real quick. But yeah, I would just use the Mark IVs in that case. Yeah, I need to update this.
It says input sharpener in the top of the picture of it in green.
Yeah, that's fine. Yeah, if you see the Mark IVs, then just use it.
Yep, but when
I'll fix my slicer later.
Yeah, but when I'm done with that, it doesn't say sharper input in the name after I'm done
Fine.
selecting it.
If it's in like the icon for the printer, that it'll tell you that it has it. And most newer printers do have it anyways.
Okay.
So yeah, if you are on a newer version, I'm assuming, then it should be the Mark IVs. So yeah. That being said, because everyone will be on the Mark IVs, your time might look a little bit different compared to mine. So yeah, because I think the Mark IVs is a little bit faster than the Mark IV. But I don't want to update it right now because it'll take a minute. But anyways, to import your model, you can just drag and drop the file from your file explorer, or you can press like Control I and it'll open your file explorer. I believe you can also do file import and then import STL, and then it'll bring your model in. Is everyone good here? Assuming that you have the latest software, use the Mark 4S. Yeah, I should have updated this today, but I didn't.
Wait, can you go through that one more time? So sorry.
Yeah, I mean, you can just drag the file in, or do file import right here, or Control I. Literally any way you want to put it in, it'll get in there. Yeah, I use Control I because, I don't know, just a preference.
Thank you.
Yeah. But you'll see here that our 3D Benchy is placed on our build plate here. It's oriented in the correct orientation, at least for what I want. If you wanted to change that, you can change it by, this move here or just dragging it around. You can also place it on a certain face with this on the left here. So sometimes when you import a model, it may not be in the orientation you want. I like using the place on face tool because then it'll place it on, whatever flat surface that you choose. In this case, you don't really need to mess with it, but I'm just kind of showing you the UI. You can also change the scale. So if your part was too small or too big, and you wanted to make it a different size, you can use the scale tool here and change it over here or drag these little squares. And then you can rotate it, spinning it around. If you have multiple parts, this arrange button is nice. So it'll automatically kind of put all the pieces equally spaced apart, just so they aren't touching each other. The delete button is here if you want to delete a model, or you can just press the delete button. Copy paste, all that fun stuff. Over here you can add, oops. Oh, I didn't realize you can add your model there as well. So there's actually 4 ways. But yeah, this is our model in our build space. But now we want to slice it, right? So I'm just going to show you what it does. I'm going to slice it to start, but we're going to start to change settings in a little bit. But when you slice it in the bottom right, the computer will kind of take its time and then generate a toolpath. Give it a second. Okay, cool. So it generates a toolpath for your printer to follow, right? So if I go over here to like the preview, like before it's sliced, you can see if I zoom in, it's really smooth and stuff like that. But when I go to the sliced preview right here, you can see how the printer has, or this model now has layer lines and stuff like that, right? So this is a more accurate representation of what you're going to see when you take your part off the printer. So you can see it's technically not a perfect representation of your part, but it's pretty close. When you slice it, you can see there are these bars that go up and down and left and right, and it'll allow you to preview the different layers and tool paths, right? So if I use this vertical slider and I slide it up and down, you can kind of see how the part comes to be. So I'm going to start way at the bottom. I'm going to drag this all the way to the start. And you see it starts with nothing. But as I drag this line or this slider to the right, you can see this arrow is representing the nozzle, and then you can see the tool path it takes, your printer takes, and then it fills in all the areas of your model, right? So in this case, the first layer has some text at the bottom, and then it fills in everything else, and that's the first layer. And you can see as your printer prints, it takes those slices that the slicer made and it stacks them on top of each other till you get your print. It's pretty fascinating to look at when it's actually printing, but this is a good representation of what it's going to look like. You can also see the different features here, right? Prusa Slicer does a good job of highlighting the different kinds of features. But you can see here, like this infill is like this red here, and the perimeters are orange. In this case, it has two walls, right? And then it's at 15% infill, at least in this scenario. So using this preview, you can kind of get an idea of how hollow your print might be or how thick the walls might be. So now that we know how to slice stuff, we can go in and change it or change certain parameters. Just keep in mind that every time you change a parameter, you're likely going to have to reslice the part. So if I wanted to change the infill density, I could change it, but then I have to reslice it because it has to recalculate the tool path. So I'm just going to get started with the slicer assignment. Oh, should be the Mark IV. So in our case, we have a couple of parameters that we want to follow. So we want to change the number of perimeters. We want to change the layer height, the infill, and then we're going to turn supports on. Generally, for the 3D Benchy, you don't want to run supports, but for this assignment, I'm going to ask you to turn them on just so you kind of know how they work. So over here, I'm going to start with the perimeters. Again, we're using Prusa Slicer. We have the Mark IV. So I'm going to start changing the settings. So we want to set the perimeters to 3. So if I go back to the slicer and I go under print settings, I can change the number of perimeters right here under layers and perimeters here. And then I can change that to 3. I also want a 20% infill. So I can go on the infill tab right here, then change it to 20%. There's a bunch of different patterns that you could go with, but just leave it at grid for now, just so it stays consistent and the time is correct. For the resolution, you want to select the 1.5 millimeter layer height. Speed profile doesn't exist on the Mark IV, pretty sure. Oh, it does. Okay. Well, you want to choose the 1.5 millimeter speed profile. Sometimes if you change settings before you change the profile, it'll ask you if you want to transfer them. I'm going to transfer them because those are the ones I wanted. And then I'm going to turn supports on. So if I go back to the 3D editor view on the bottom left, Benchy will appear. And then I can enable supports. So I'm just going to set it to everywhere, just so it'll automatically generate supports where it thinks it needs it. Again, when you print one, you generally don't use it, but I'm just enabling it so you know where it is if you need it. So with all those changes, I'm gonna have to slice it again. It'll compute a new toolpath. And here it is. You can see here that the Benchy now has supports on it. So all these green things here are there to support the model. Again, in this case, you generally don't need it, but this is just for, you know, testing purposes, so you know how it works. You can see that the slicer will display like information like how heavy the model is and like how long it will take to print. And then you can kind of mess with it and see how different settings will change these end results, right? So if I changed the supports to none, it was about an hour and a half before. But now when I slice it, you see it's like an hour and 5 minutes, right? So changing settings, adding material can, increase print time. In our case, for this assignment, I'm leaving it at everywhere. $48.05. Okay. I'm not sure because I don't have the Mark 4S, so I'm gonna open it again. It'll ask me to update.
So should we use the Mark 4S or the Mark 4?
Use the Mark 4S. I'm sorry for the confusion. My Crucial Slicer is not up to date. Just give me 1 second. Does anyone have any questions on the slicing stuff?
Mine says error, conflicts in G code paths have been detected.
Conflicts in G code? Do you have like multiple models overlapping each other? Sometimes it throws an error if you do that. Sometimes it just throws an error for no reason.
I should only have one open.
Let's open this up.
Yeah, 3 weeks to be promised. We're gonna do a full. Some great.
How do I fix it?
Okay. Um, so you want to choose this printer here. I'll add a screenshot and put it in the Discord later. But you want the Mark 4S with the 0.4 millimeter nozzle. It won't say input shaper because the input shaper's in the icon. So yeah.
So if I accidentally choose the other one, can I change it later on?
Yes, you can.
See you later, Jesse.
So if you wanted to change your printer, you can go under the printer tab and then do add or remove printer and then add or remove presets. And then it'll open up that window and then you can select the printer that you want. In my case, you see I have a bunch of printers, so I can choose between them if I like enable all the check marks. I'm gonna slice this real quick. Okay, yeah, that looks right to me. Yeah, Jack says 1 hour, 20 minutes for normal and a little over an hour and a half for stealth. So I have the same thing. Sometimes like there might be slight rounding differences. So it might be like an hour, 20, 19 minutes or something. I'm not going to go super crazy into that. As long as it's pretty close, I'll kind of know that you did it right. Again, if you had like a setting incorrect, like for example, if I had the infill at the wrong setting, you'll see that the time is different. So I'm going to be going off the time for this assignment. So make sure it is at that hour 20-minute mark for normal mode. You can see here when I set the infill to 60%, it changed it to hour 29 minutes, right? So it's pretty easy to tell if something's wrong because the time will be off.
How do I turn on the supports?
So right under the printer tab, there's a button that or an icon or drop down that says supports, and then I set it to everywhere. Okay, that is a good question. What should you include in your screenshot? So the main thing I want to see here, see in your screenshot is this information down in the bottom right. But if you just screenshot your whole screen, it'll give me a better idea. Here, like the info and layer height and material, along with perimeters all specified. So the only thing here that's missing is number of perimeters. And again, if your time was off, then I would know that you didn't do your perimeters correctly. So yeah, for the screenshot, just screenshot the whole thing. You know, it's proof that it's a benchy. It has like almost all the settings here, and that's enough for me.
Andrew, how do you switch the supports on? I think I missed that.
So to enable supports, you can just go under the printer tab and it has the support drop down right there.
Okay, everyone. Okay.
You should also be able to change it if you go under print settings and then support material, and then you can check the generate support material here.
Thank you.
But yeah, this is just kind of the beginner mode for slicing. If you start to get more advanced and you want more settings, you can just change the drop down. I usually just leave it on expert just because it gives me everything I need or I might want. And then you can see when I enable it, a lot more things get unlocked. Um, a lot of things are just things I don't really change very often, but it's nice to know that it's there. So I usually leave it like this. But in general, the main thing that you want to change is your layer height, your material, uh, your infill, the perimeters for here, and then supports. Another thing that might be helpful, this isn't part of the assignment, but this is just something that might be good to know. Prusa Slicer and a lot of other slicing software have something that is called paint on supports. So if you don't want the computer to assume where you want your supports to go, you can manually tell it where to put supports and where to not put supports. So it can be useful for certain models. Obviously, the Benchy isn't really a good example because it doesn't need supports. But you can like right click or left click certain areas and then it will enable supports. So left clicking is blue, which will enforce supports there. And then right clicking is red and it'll block supports. So if there's a specific spot that you don't want supports, this is a useful tool. Generally, I use the support blocker more than I use the support enabler, but that's just kind of me. The smart fill is pretty good sometimes if you want like to, fill in like a nice square surface or something like that. It will, fill in everything. In this case, it just did the whole hull, but yeah, it's a useful tool. Again, that's not really part of the assignment, but it's just something that's good to know. Um, you don't really need to change your units. The slicer kind of assumes it for you. I mean, if you prefer inches, you can enable inches, but it doesn't really matter. It's just a preference thing. Yeah, if any of your slice times looks weird, make sure all your settings are correct, and then make sure your filament type is PTG. Because it's again, if it's not PTG, it might be different. But yeah, that is the basics of slicing. Does anyone have any questions?
Where can I find the then,
Sorry, can you say that again? I think two people were talking.
where can I find the resolution?
The resolution. So it's on the top. So it's under print settings, and then you can specify the layer height here.
Okay.
Personally, I just almost always keep mine at 0.2. But again, that's just kind of my use case, depending on your modeling, but not more or less resolution. But yeah, 0.2 is like pretty typical.
When I try to slice this, it gives me an error saying that conflicting G-code paths have been detected at layer something.
Let's see. Yes, if you finish slicing, you can do the quiz. If you didn't know, there is a quiz today, but like don't freak out because you have infinite attempts. This quiz is mostly just for your education, just to learn a little bit more about printing, and hopefully you're paying attention and you can get most of it right. But it should just be Google form. You can take the quiz. And that's basically it today. I'm going to go over some of the limitations of 3D printing. Um, but in terms of assignments, it's just this and the quiz today. This limitation section might be useful when designing your final projects. Okay, so if any of you are having trouble with this slicing assignment, I'm just going to move on and talk about the 3D printing limitations. And if you want, you feel free to stick around after class or just send photos or DM me, and we can work this out. But yeah,
Sorry, Andrew, I try to get a screenshot. It doesn't let me take a screenshot of the screen when it's the slices on.
oh, that's weird. Okay, do you wanna wait till after class and we can figure it out?
Sure, no problem.
Okay, cool. Thank you. All right, so now that you kind of know how a 3D printer works and how the slicer works, we're going to go over some of its limitations, right? I wish I could say that the 3D printer can create absolutely anything that you want, but it can't. It can do a lot of things, but not quite everything. So like every manufacturing process, it has its limitations, and those limitations are something you want to keep in mind when designing parts for it. So one of the main things that people will talk about for 3D printing is an overhang, right? So basically, because of how 3D printing works, right, you're stacking layers on top of each other. Um, those layers have to overlap, at least somewhat overlap, right? And if they don't overlap, then it can droop and fail. And that's what we call an overhang, right? So you can see here on the top left here, this is not a very steep overhang. You can see this angle, at least going up, is not very steep, right? And the overlap between the different perimeters is pretty high. So if you have a shallow overhang like this, your print is more likely to succeed. But as you go more and more outwards and more aggressively, the amount of overlap between the parameters becomes less and less. And again, it will droop, and it could fail. Um, Depending on your design, if you need that overhang, um, you can get that geometry by adding supports if you really need to. But again, as a designer, you can do your best to design those overhangs out of your model. Generally, a good rule of thumb is just like don't make your overhang more than 45 degrees. A lot of printers are capable of doing more aggressive angles than 45, but 45 is a general rule of thumb. And also nice even in the middle between 0 and 90. So, adding a chamfer is technically like a 45-degree overhang. Or it's a 45-degree angle, or at least the standard of chamfer is. So if you chamfer something at a certain orientation that is just 45 degrees, it's not a steep overhang, and your printer should be able to reproduce it. So yeah, when designing your final, if you have an overhang, keep this in mind, because I really don't want to print supports because it takes more time and more material. And depending on your model, if it's really thin, then that support might break your model as you take the support off. Something to keep in mind is a vertical hole is technically an overhang, right? If you think about the hole and you draw like a line tangent to it, as you go farther and farther up the circle, as you near the top, the angle of the tangent line on the circle becomes more than 45 degrees, right? So you can see here on this printed piece, the top of the circle looks kind of droopy, and it's because it's an overhang. This issue is, exacerbated as your hole gets bigger, but there's a couple ways you can go and combat this, right? You could enable supports, right? Your print will print sacrificial material and then you have to break it off. But as a designer, you can add stuff into your model to make it more printable, right? So you can see here in the middle, there's this circle and this arch, and you can see here that it droops, right? And as a designer, you can change that by modifying it just slightly. And what I like to do for holes and arches like this is I like to add this kind of teardrop shape on the top of the hole. So if you go into Fusion and you make it, these two lines are equal length. I usually set them to be perpendicular, and then I make sure, the top of the teardrop is aligned vertically with the center of the hole. So again, those are a couple of geometric constraints that I use to make this teardrop. Oh wait, the other one is to make sure that these lines are tangent to the circle to ensure like a smooth transition. But those geometric constraints should be enough to create that teardrop shape for you. And again, because these two lines are perpendicular to each other, the overhang angle at the top of this teardrop is 45 degrees, right? And again, 45 degrees, it's a good number. The printer should be able to reproduce it, and life is good. If you're concerned about like the dimensional like accuracy of something like this, I use like this teardrop shape all the time on 3D printed parts. I have bolts going through it, and it's not really an issue at all. So, unless you're like you really need some insane dimensional tolerances, this teardrop shape is perfect for most applications. If you need more accuracy, then like you should probably consider a different manufacturing process because FDM 3D printing isn't the most precise. I think it's about plus or minus 0.1 or 0.2 millimeters. So if you need something more accurate than that, then you might want to choose something else. But yeah, I'm kind of on topic. You just want to, or this teardrop shape is a good way to mitigate this drooping. One of the other big things for 3D printing is bridging. So if you think about a bridge, it's technically a 90-degree overhang, right? Spanning across two different places. So, it's going to droop to some degree, especially if your printer isn't tuned in very well. And the longer the bridge, the worse the drooping gets, right? So you can see here on this gray bridging test that, if the bridge is short, then it may not be too bad, but as you get longer and longer, it droops more and more. And, that might ruin the look of your part or just ruin the accuracy of your part in general. So you want to try to avoid designing long bridges in your parts. Again, if your part needs that geometry specifically, you can add supports to support that bridge. But if something like this bridge is unsupported, it will droop. So please don't make very long bridges. I've said this in previous classes, and then someone has given me a model of a bridge. So please don't do that. I don't want to print Golden Gate bridges just because, it's going to use a lot of supports, and you don't want that. The other thing you want to keep in mind is 3D printing tolerances. I talked about it like a couple slides ago a little bit, but 3D printing isn't the most precise manufacturing process out there. It's pretty good, especially nowadays. It's pretty accurate, but there's always a little bit of leeway, right? Um, the tolerances can range. And my printer's tuned in pretty well, so it's usually like 0.1 or 0.2. But depending on your printer, it could be more up to, 0.4 or even more. This is partially because of the process of the manufacturing. Because you're heating up the material and cooling it down, it's subject to thermal expansion, right? So it'll, kind of grow and shrink depending on how warm it is. So when you print it, it might print oversized, but then once it cools down, it might shrink. And then part of that could cause, your design to warp. So you can see in this photo here, this corner is lifted and it's completely warped this, rectangular container looking thing. So part of this may have been a bed adhesion issue, but parts can warp depending on the material and the printer. They could be more or less prone to warpage. So keeping that in mind, you don't want your prints to warp. That's more of a tuning thing, but just know that that's a possibility. Elephant's foot is a little bit different. Um, it's kind of a term that 3D printers people use for like excess squish on the first couple layers. So sometimes to get good bed adhesion, people print their first layer a little bit like squished, right? So it might say it's 0.2 millimeters, but they actually push the bed up a little bit, or they just reduce that layer height to get better bed adhesion. And sometimes it can result in something, called elephant's foot, when the first couple layers squish outwards, right? So you can see here in this like blow up photo, the first two layers are kind of sticking out, and then the rest of them are pretty linear and straight. So sometimes that can happen, and depending on your model, if it's interfacing with other pieces, this elephant's foot could get in the way of your dimensional accuracy. One way I like to mitigate it is just by adding chamfers. So if I chamfer this edge here, even if it elephant's foots out a little bit, it will still be, in line with the main surface, unless your elephant's foot is really, really bad. So if you ever look at some models I made for 3D printing, I just kind of put chamfers like everywhere. One, because it looks nice, but also if I'm printing it on a certain face, I like to chamfer the edges where I can, to reduce the effect of elephant's foot if that ever arises. Here it says test prints can help you dial in settings. That is very much true. I've been printing for a long time, and a lot of my prints are just calibration prints. Nowadays, that's like becoming less and less common because printers are getting better and better. But printing a couple test prints is always good practice whenever you get a new printer or you're testing the material or something like that. Here's a good example of like the thermal expansion that we talked about earlier. This is actually one of the final projects from a previous class. This person modeled like a Lego-like figure, but when they went to assemble it, the torso didn't fit onto the body, right? And then in the CAD, because you're working in a virtual environment, you can make it fit perfectly, right? And they may have not added tolerance to this, which caused, the torso to not match up with the body. So keeping that in mind might be good if you're designing parts that interface with each other. generally I like to use like 0.2 millimeters a lot. Um, yes, we'll get into that. So generally, I like to use 0.2 millimeters as like a general like idea for tolerancing. It's pretty well for me. Obviously, like you asked, like your printer does affect the amount of tolerance that you might need to add. But in general, 0.2 millimeters is a pretty good safe bet, right? So, um, I work a lot with like metric hardware whenever I make parts. I make a lot of things that use M3 bolts. And for the clearance for the M3 bolt, the bolt is 3 millimeters in diameter. But when I make my hole, I make it like 3.2. So typically some fit after the thermal expansion. It works out pretty well. Um, but you are right. Um, Depending on your printer, it may warp or more or less, or depending on how accurate it is. Um, but it's something to keep in mind. Again, 0.2 is a good safe number to start with, but if your printer is like especially bad, you can change it, or if your printer is especially good, you can change it as well. Okay, yeah. The quiz, if you haven't taken the quiz yet, the quiz is available on the Discord. Again, it's just more informational for you. It's low stakes because you have infinite attempts. So feel free to take that. The one thing that I will add for designing for 3D printing is please don't make your things really, really small, right? So if you go back to your slicer, you'll see that the printer's nozzle is 0.4 millimeters diameter, right? So that means if you have like a feature that is smaller than that number, it will become very difficult for the printer to reproduce. So please don't make anything smaller than that. Generally for stuff like walls and stuff, I like to keep it at like a 2 millimeter like minimum, and that's like absolute minimum. I try to keep things like at least above 3, because anything smaller than that might have a tendency to break depending on the geometry. Um, so again, when you go to design your finals, please don't make super, super thin parts, because if that does happen, um, there's a higher risk of your part breaking once you receive it, or even breaking as I'm taking it off the print bed. So yeah, please don't make really small things. If you ever had like have questions about your final and like how like manufacturable it is, feel free to like send a photo of it to me or something and I can give you feedback. Um, but yeah, a lot of it is just kind of using your judgment. And your judgment um may improve over time if you start to use printers more and get a better feel for what printers can. But my general rule of thumb is like 2 or 3 millimeters for a minimum. Um, and you should be golden. For max size of your final project, please be reasonable. Because remember there are, I believe 71 students last time I checked. So I could be printing up to 71 finals. So please don't, ask me to print something like 10 inches wide. Because, it's a massive part. It's a lot of filament and might take a lot of time. So for max size, I'm just gonna say be reasonable. If your part is too big, I might just scale it down. But you know, if it's something that needs to be a certain size, um, if I scale it down because it's too big, like, you know, that's just kind of sad, right? So please be reasonable, use your judgment. Again, I'm one person. I have a couple printers, but printers take time and I want to deliver them all in a somewhat timely manner. How do you submit your final project? I'll open the submission for the final next week. on the last class. But that's where you're going to submit your final project along with the rendering, and I believe one or two more things. So don't worry about submitting your final yet. That'll be next week. And again, it's due a week after the last class. So what day is that? October 8th. So yeah, your final is due October 8th. I'll just say October 8th at midnight, right? So you have till midnight. Please get it in so I can grade it and then start printing it if you want. But yeah, other than that, we're going to be wrapping up pretty early today. Feel free to stick around if you have more design questions. I'm happy to answer them. Or if you're having trouble with, the slicer or any of the other stuff, you could ask me. Um, I will see you in person next week, hopefully. I will let everyone know when I get a room and stuff, and I'll post like the location and wherever, and all that good stuff. Again, fill out the attendance form, please. Because if you don't, you won't have food. So yeah, fill it out. If your friends are in this class and they aren't here, tell them to fill it out. But yeah, other than that, you're free to go. I'll see you next week.
Thank you.
Oh,
Oh yeah, I had a question.
yeah.
Yeah, what's up?